Hi, my name is Katie Clark, and I'm going to be talking about the science behind the Martian, what they got right, and what they didn't get right. So, to start off with, I'm going to be talking about the atmosphere on Mars, how it compares to the atmosphere of Earth, and the difference between what is seen in the movie versus what is actually in real life. So, the atmosphere on Mars is much thinner than the atmosphere of Earth. It's mainly composed of carbon dioxide, nitrogen, and argon, which is much different than the composition of Earth's atmosphere. Because of this and some other reasons like the gravity, Earth's atmosphere is over 100 times denser than what is seen on Mars. Now, a big plot point of the movie that kind of sets everything into motion is a huge dust storm that comes along, and it separates our main protagonist from the rest of his crew as they are on Mars, and his crew leaves him for dead, thinking that he is dead because of the severity of the dust storm. Now, while Mars does have dust storms, what is depicted in the movie, because the atmosphere is so thin that the 100-mile-an-hour winds on Mars would really only compare to about 11 miles per hour wind on Earth. So it would barely disrupt you walking, much less rip a spaceship up from the ground. So this is a little bit of an unrealistic part of this movie, but the screenwriter said that this is something he was willing to overlook to kind of add to the story and set everything in motion. The next thing I'll be talking about is the gravity on Mars. So the gravitational force on Mars is roughly a third of the gravitational force on Earth. Here I have some of the math. So the equation for finding the gravitational force of a planet is the gravitational constant times the mass of the planet, both of those divided by the radius of the planet squared. So on Mars, we have the gravitational constant 6.67 times 10 to the negative 11th times the mass of Mars, which is 6.42 times 10 to the 23rd, divided by the radius of Mars, which is 3,396.2 times 10 to the third meters squared, which gives us about 3.71 meters per second squared. And on Earth, I can run through the calculations again, but it's pretty widely known that the force of gravity on Earth is 9.8 meters per second. We have the gravitational constant, the mass of the Earth, which is 5.97 times 10 to the 24th kilograms, and the radius of the Earth, which is 6,378 times 10 to the third meters. And if we compare those two numbers, we see that it is roughly about 1/3 of the gravitational force. So because of this, as you would expect, you would feel much lighter on Mars rather than on Earth. And while through most of the movie that is seen to be consistent, as our protagonist is walking across the surface of Mars, he has a little bit of a hop in his step because he's so light, and how he can move such heavy equipment that is supposed to be very heavy with ease. There is a part of the movie where he is shown to be really struggling to climb up a ladder. So it's just not consistent throughout the whole movie, but generally they have the gravity correct. However, there are a couple scenes where it doesn't seem to be lining up. Now, one interesting thing that our protagonist does is he creates water from rocket fuel. And he does this so that he can survive on Mars for a long, extended period of time and be able to grow crops. Later, we talk about this, but he grows potatoes. And so he creates water from the rocket fuel using hydrogen and oxygen that is available to him. Now, in theory, this would work. The process that he uses during the movie is a way to do it. However, there are better ways to do it, just using water that's in the soil on Mars. But the biggest issue with this in the movie is how risky and dangerous it would be for him to make water out of the rocket fuel. Like I have on my slide, the hydrogen in its pressurized form is very toxic to humans, and oxygen is very explosive when it's pressurized. And since our protagonist lacks equipment to handle these chemicals, these elements safely and effectively, it would more likely just blow up and end quite poorly for him. Now, one thing that our protagonist does is he starts to grow potatoes on Mars, and that's something that is actually very plausible. The soil on Mars would be able to grow crops. There are plenty of studies that have been done and are still being done to verify the validity of that and see if we move into space exploration in the future, whether growing crops on Mars would be feasible. And our protagonist using feces as a fertilizer would actually work quite well. He would have to watch out for some of the pathogens that come with that, but as long as he were able to safely and effectively clean that and make sure that it wasn't going to transfer into his crops, he would be able to do this. Because Mars's atmosphere is also so rich in carbon dioxide, these plants would be able to really thrive because of that, and they would provide extra oxygen for our protagonists. However, the lack of sunlight on Mars would pose an issue, but that could be made up for using specialized lamps and other products. But overall, it is quite feasible for him to be able to grow crops on Mars. Now, one issue that isn't very talked about or shown throughout the movie is how sick the astronauts would be after returning from Mars due to the radiation that exists there. There's a lot of radiation that exists on Mars, which can be blocked using specialized coverings and clothings. And this is an issue that isn't really covered in the movie or in the book, but they should be getting really sick with radiation poisoning from the lack of protective equipment that they have to handle it in the movie. However, in real life, that is something that could be avoided using the right equipment. One of the really interesting things that this movie gets right is some of the orbital mechanics. So something that is used throughout this movie is a gravity slingshot. So as the crew realizes that their friend is alive and they need to go back and rescue him from Mars, they use the gravity slingshot to go around Earth to gain some speed and change their trajectory to get back to Mars and rescue their friend. Now, this has actually already been performed by Voyagers 1 and 2 to get outside of the solar system, so it's something that is real and something that is done correctly in the movie. So the idea behind this is using the equation F equals gravitational constant times the mass of one object times the mass of another object, all that divided by the radius of the bigger object squared. The closer that the item with the smaller mass gets to the item with the bigger mass, in this case the planet, it will use the planet's gravity to either speed up or slow down, depending on whether it's going into or away from the planet's orbit around the sun, and it will slingshot around to get away from the planet. So this is a part of the movie that they definitely did get right. So, in conclusion, there's a lot of things that this movie did get right about space and the mechanics that they're using with the orbital mechanics, growing crops on Mars, being able to create water from rocket fuel, although maybe not super effectively. And there's also things that this movie got wrong, like the windstorms that you would see on Mars, just the inconsistency throughout the movie with that, how the gravity was inconsistent. But overall, this is a really good movie that does a really good job in sticking to the scientific facts, and it does a great job in portraying those things in a way that's easy for watchers to understand. Thank you.